Yes. Which are the single cell microorganisms? Like there are some group of microorganisms in which all the microorganism will be single celled. Isn't it bacteria? All the bacteria are single cell organisms. Getting it, Vaiga?
Okay, sir.
While the alga, they can be unicellular and multicellular. Fungi can be unicellular and multicellular. Viruses are also unicellular and multicellular. Same
Okay.
the case with the protozoans also. But
Okay.
bacteria can be all of them are unicellular. Out of all the different groups of microorganisms, which one of them is smallest in size?
So what?
Out of all the different groups of microorganisms, which one of them is smallest? Are the
The
bacteria
smallest
smallest
one?
or the virus? Yeah. Is it the bacteria that are
Bacteria.
smallest or the no? Actually, it's the virus. Virus are the smallest microorganisms. Okay.
Okay, sir.
Okay. That is one thing. Okay. Do tell me, the disease typhoid is caused by a virus or a bacteria?
Disease?
Typhoid is caused by a bacteria or a virus?
Virus.
No, it's not caused by a virus. It's caused by a bacteria by the name of Salmonella typhi. Okay, now
Okay, sir.
Salmonella typhi causes this. Okay. Yes, Reem, how are you? So it's caused by the this bacteria. Okay, now
Okay, sir.
further answer one more question to me. From the same chapter, microorganism. Who discovered the first antibiotic? Who basically made the first antibiotic? Yes, was it Alexander Fleming? Was it Edward Jenner? Was it Robert Koch?
Hello, am I audible?
Yeah, you're audible. How are you?
I'm fine. How about you?
Yes, I'm also good. So right now we are actually
So it is Edward Jenner.
no.
No?
My question to both of you is that okay, Reem, you also continue from here. Who was the first? Who was the person to have discovered the first antibiotic? I can give a hint. The name of the antibiotic starts
I
from
got it.
C.
Alexander Fleming.
Alexander Fleming. Okay, na?
Yeah.
Okay. By the way, Reem, tell me what's the update? What's going on in the school? Which chapter is going on?
Right now in school?
Mm-hmm.
Well, in biology, we are still on another block on microorganisms, and we have started another block in chemistry, like about minerals and all.
Minerals.
Sorry,
Okay.
metals, not
Metals.
metals.
Okay. And
And in physics, we are doing force.
force is going on.
Yeah.
Okay. And what's the update on your exam? I suppose last time you.
Exam? Yeah, actually, my exams are gonna be in November. Yeah, November.
Have you got the date sheet?
No, we haven't yet got the date sheet.
Haven't got it yet.
Yeah.
It will be on November. So you also haven't got the syllabus yet.
No, not this syllabus.
Okay. So you have not received the syllabus from the school. When you get it now, Areem,
Huh?
update whenever you get the syllabus now, share it with the team.
Huh? Okay.
Am I taking your name correctly, or is it have you joined from a different ID?
No,
Oh,
it's like a short form of my name. It's actually Harim.
Harim. Okay.
Yeah.
I actually forgot it. You told me the same thing in the previous class.
Yeah.
Okay. So right now, what we are doing now, we are not starting a new chapter. Okay.
Mhm.
Right now, we were just revising some of the concept from the previous classes. Okay. Once we are done with this, for the next 15 minutes, we are going to revise some of the questions from the different chapters that has been done in the batch so far. Okay. Particularly I'm going to discuss questions from those chapters which is there in which will be probably there in your upcoming exams. By far, what you have, the information which I have. Okay. So it was penicillin that was the first antibiotic to have been discovered by Alexander Fleming in the year 1928, right? What about the first vaccine?
Oh. We discussed it in the last class.
Sir
Yeah.
Edward Jenner for like smallpox.
Right?
Yeah.
So Alexander Fleming in the year 1928 discovered the first antibiotic. Okay. By the way, this penicillin, it was extracted from a fungus, or was it extracted from a bacteria? Yes. There was a fungus by the name of penicillium, okay, now, from which the penicillin is derived. It was extracted from this fungus by the name of penicillium. Got this, both of you? Talking about the vaccine, it was, as you have said, Edward Jenner, right now. So first vaccine was developed by a physician named Edward Jenner in the year 1796 for the disease smallpox, right now. So that was the first vaccine by the Edward Jenner. I have another question for you guys. When we talk about disease, so disease can be disease can be bacterial disease, it can be viral disease, it can be caused by the fungus. So they are fungal disease. Then there are some diseases that are caused by the worms also. So I want all you guys to give one example of each type of disease. Give one example of a bacterial disease. Each one of both of you give one example at least. Give
So
an example.
bacteria, typhoid.
Okay.
Diarrhea.
Okay. And give example of viral disease.
Chickenpox.
Chickenpox and
Corona.
yeah, COVID-19. And we have some other, like we have some other disease like Ebola. Ebola is also a disease that is caused by the Ebola virus. Good. Flu, or basically influenza. Okay. Then give some example of fungal disease. Disease that are caused by the fungus.
I
Yes.
know a disease, but I don't know the name exactly.
It starts from R.
No, I don't know the name. It's
Okay.
like it happens when like the water touches the feet, I think.
Basically, it happens to the athletes.
Yeah, the feet.
Okay. That is called as athlete's feet. Okay, na?
Yeah.
So the athlete's foot, actually.
Mhm.
Getting it? Why are you also?
Yes, sir.
Athlete foot. Okay. Then this one is the ringworm. Getting it? The ringworm. So ringworm, athlete foot, these are some of the fungal disease. So in this situation, rashes will develop on the skin. There will be itchiness on the skin. The part of the skin which has been infected will become red. Okay, and it will be giving you a burning sensation. That is one thing. Okay. By the way, we know that there are some diseases. There are some diseases that are caused by the worms. You know, there are some diseases that are caused by the worms also. And there are some worms that lives inside the intestines. Like you guys have heard of teniasis. It is a tapeworm, exactly. So there's a worm that lives in the intestine by the name of tapeworm. And it has a shape kind of like this. 1 minute. Let me just show an image of this. Tapeworm is there. There is other kind of worm like filariasis is there. Have you guys seen that many times now? The feet of the person would become swollen. The feet looks like that of the feet of the elephant. You guys getting what I'm trying to say? Many times we see that the feet of the person will become like that of a elephant, and that is called as elephantiasis. By the way, this is the tapeworm, and it could be several feet long. It could be several feet long. Once I heard a news that there was a man from whose intestine tapeworm, tapeworm of several feet was extracted from the intestine of a person. Getting it now? So that is one thing. Like it could be like at least it could grow up to like 15 feet in length. Getting what I'm trying to say?
Yes, sir.
15, not 15 feet. I would say like 7 feet. 15 feet, not 7 feet. So this is the image of the tapeworm. Got this now? That is the tapeworm. And then there's a elephantiasis that is also caused by the worm. Okay. From the chapter coal and petroleum, also I have some questions for you guys. Do tell me why the coal and petroleum are called as fossil fuel?
Because they're made up of fossil.
No. Yes, Vaiga. Why coal and petroleum are called as fossil fuel?
Because it is made up of dead remains of plants and animals.
Right now, that were buried deep inside the crust of the earth millions of years ago. Right now, and while they were decomposing, they were exposed to high pressure and high temperature. Right now, so thereby the organic matter present in them converted into the fuel. Right now, and what we know that the word fossil, the term fossil basically refers to whatever preserved remain of ancient organisms are present, that is called as fossil. No, like we have the skeleton of the dinosaurs, we have the skeleton of the woolly mammoth, we have the skeleton of so many organisms that are no longer present on the earth. So what is fossil? Fossil is the preserved remains of ancient organisms that we have today. And coal and petroleum, they are also preserved remains of the ancient organisms, but they can be used as a fuel. They can be burned to obtain energy from it. Getting it now? That's why they are called as fossil fuel. Okay, now? Okay, that is one thing. From the chapter coal and petroleum, we have one more question. You guys tell me, when the destructive distillation of coal is done, what are the products that we obtain from the destructive distillation of coal?
Coke,
Okay, and
coal tar,
coal tar and
coal gas.
coal gas. Reem, this chapter has been done in your school?
No, not yet.
Not yet. Okay, anyways, no issue. Combustion and flame, what about that? Not yet.
Heat. Oh yeah, it's actually done.
It's done. Okay. Do tell me, in the chapter combustion and flame, you'd have learned about calorific value. Both of you would have learned about
No,
calorific.
not like a chapter, like a proper chapter, but there was a lesson.
Okay. Have you
Yeah.
heard of the term calorific value?
No.
Okay. Explain. Both of you explain what is calorific value.
I don't know what it is.
Okay. Any one of you?
No, sir.
Basically, calorific value is the amount of heat that is given upon burning 1 kilogram of a fuel when complete combustion takes place. Say, for example, if I were to take 1 kilogram of coal and if I were to completely burn it, not partially, so the amount of heat that will be given off upon complete combustion of 1 kilogram of coal or any other fuel, that is called as its calorific value. Getting it? Rima, I have one question for you from the chapter materials, metals, and non-metals. That is there in your syllabus, right?
Yeah.
I mean, it is going on in the school in the chapter chemistry. Do tell me what happens when metals react with an acid. What is given off? Metal plus acid.
There are various types of reaction.
Mm-hmm.
Like gases form, sometimes flame.
Yes, gases form, bubbles will be given off, right?
Flame,
Flame can be formed, okay. Flame can be given off.
sparks, like oh,
Color
fire.
can change, heat can be given
Yeah.
off, yeah. In the chapter, like you would have learned about the physical property and the chemical property of metals. Same, you would have learned about non-metals also.
Yeah. Not chemical exactly, but we have learned about the physical property.
Okay. What are the physical properties of metals?
Like they're lustrous.
Hmm.
They are shiny. Yeah.
Shiny.
Some metals are shiny.
Hmm.
And they are malleable, ductile.
Malleable, ductile, good. And they have a
And
high
they have
tensile strength.
huh?
High tensile strength. They have high
Conductors?
tensile strength.
Like good conductors.
Yeah, they are good conductors of heat and electricity. Good. And they are sonorous. Upon being struck, they produces a ringing sound. Okay.
Yeah.
That is one thing. Talking about the chemical property of metals, once we'll be doing that chapter now, we'll be learning how the metals would be reacting with air, how it reacts with water, how it reacts with acid, and how it reacts with a base. Okay. Anyways, from the chapter force and pressure, you guys answer to me. what is the difference between force? I mean to say, what is the relation between force and pressure? That is the question. How force and pressure are related? And my question is, how force and pressure are related to each other? Do they share a direct relation or do they share an indirect relation? Are they directly proportional? Is pressure directly proportional to force, or is pressure inversely proportional to force? Directly proportion is a relation in which one quantity is increasing, another quantity will also increase. Getting my point?
Yes.
Huh?
Yes.
Inverse proportion is a relation in which if one quantity is increasing, another quantity will be decreasing. Okay. Like for example, if you were to increase the speed of the car, the time taken to cover the journey will reduce. So both of them are inversely proportional to each other. Speed and time. More speed, less time. Getting it what I'm trying to say? Okay, one question. First of all, you guys define pressure. And then I think you'll be able to define how both of them are related. Yes, what is pressure? Yes, Reem and Vaiga, how do we define pressure? Pressure is the force acting
It's
upon a
like
unit area. Mhm.
it's like the force acting on an object.
On a given unit area.
Yeah.
Getting a Dream and Vika. So force acting on a unit area is called as pressure, right? So force acting on a unit area, that is called as pressure. So if I were to increase the force, will pressure also not increase? Pressure is going to increase now. So both of them share a direct relation. If you increase the force, the pressure is also going to increase. Getting it now? That is one thing.
Yeah.
What relation does the pressure and area share? Inverse relation or direct relation? Do they share a inverse or direct? Yeah. Like if you were to say you have two knife, one is a sharp knife, another one is a blunt knife like this. Okay, this is the sharp and the another one is blunt. So blunt knife is going to have a more area.
Yes.
Yes,
Area is
so
more. Sharp one has less area.
Mm.
Say you are going to cut an apple and you apply a force of 10 Newton on both of it. You applied a force of 10 Newton using this knife and the other knife also. In which one the pressure will be more? The sharp knife or the blunt knife?
sharp knife.
The sharp knife.
Sharp knife, obviously. So here we are seeing that despite having applied same force on both of it, the pressure applied in this one is more. Why? The area is less now. Less area, more pressure. If area is less, pressure is more. So it is inversely proportional to each other. Getting it now?
Yeah.
Okay, that is one thing. Okay, nonetheless, let's start the class. Age of adolescence, it is not going on in a school, right? Reem, age of adolescence, this chapter is not being discussed in your school right now. Yes, you there in the class? Uh, I guess I'm audible.
Sorry, I was in mute.
Okay, okay. The age of adolescence, that chapter is not going on in your school now?
No.
No. Okay. Why can you tell me in which chapter you are having doubt? What chapter you would like to do and what's going on in your school?
So for like all chapters.
Yeah, like from all the chapters, what chapter you would like to discuss, and right now what is going on in the school? I need to have this information, only then we'll be continuing in the class. Okay. No?
Okay, sir. So just 1 second.
And team, you also mentioned this, what you'd like to do. Since your exam is on November, so on that basis only we're going to continue the class. Okay. Yes. You guys can write it in the chat box also. Which chapter you guys?
Okay. I'll just write it in the chat.
So for physics, we just finished friction and we didn't start a new chapter because it is flip teaching.
Okay, friction has been completed in your school.
No, sir. Yeah, I mean friction is completed.
Okay.
And then for chemistry, so for chemistry, we finished chemical effects of electric current.
Okay.
And biology.
By the way, Reem, whenever I will be asking you guys to answer something or write something in the chat box, you'll be required to answer on this ID. Okay, na? Send it on this ID. Yeah. Chemical effect of electric current, that has been
Done so.
done. Next.
And then for biology, microorganisms, Fend and Foe. It's the last chapter that we did.
Okay. So these chapters have been recently done, right?
Yes, sir.
Okay. Mention the chapter in which you guys are having doubt. You mention the chapter which you would like to do in the batch right now, and Reem, you also.
I'm having a bit of doubt in the metals and that part. Actually, balancing the equations of.
Okay, got it. Balancing the chemical equations. In that you're having doubt. Okay. Vaiga, what about you?
So actually, I study these all chapters like the exam's just over. So I'm okay with what Reem is telling.
Okay, let's do that. Okay. Actually, like the thing is now, like everyone is having kind of their different schedule and different syllabus going on in their school right now. So it's kind of difficult to come to a common conclusion sometime. Okay. Some students, their exam is already over, like Ibrahim, Aisha, so they are not continuing right now. They will be after a few classes, they will be continuing. Okay. So let's do one thing. Let's learn about the balancing of the chemical equations. Vaiga, do you have this chapter in your syllabus? This materials, metals, and non-metals?
Yes, it is there. But then we didn't take that in a class in a school.
Okay. Anyways, so talking about the balancing of chemical equation, let us understand this. This topic might not be there in your school, might not be taught to you, but it will be helpful for you also, Vaiga. Okay, na?
Okay, sir.
So you also learned this. Okay. So first of all, we need to understand that what is a chemical equation. Even before that, we have to understand what is a chemical reaction. So before we learn about balancing, first we need to understand what is a chemical reaction. So in the nature, we see that, for example, take the case of the rusting of iron. So where the iron is going to react with it is going to react with oxygen and water, and it develops a layer of rust on it. Right now, getting it, guys? So there, what basically happens? Say, for example, you have oxygen that is represented by O2, plus you have, first of all, let us take iron, and that is represented by the symbol Fe. Okay, now, so you have iron, you have oxygen, and you have water, and that is the chemical formula of water is H2O. So when the reaction takes place, so what we see that, say you had this iron nail. So on the iron nail, a brown coating develops, and that brown coating is basically rust. Rust, or also we call this as iron oxide. Iron oxide, and the chemical formula for this is Fe2O3.H2O. So chemical reaction is basically what? Whenever two substances would be reacting with each other to form a new substance, that is what a chemical reaction is. That is what a chemical reaction is. Getting what I'm trying to say? Okay, no? So chemical reaction is the when two substances react with each other to form a new substance, that is called as a chemical reactions. When two, let me just define this, when two or more substances reacts with each other to give a product is called chemical reactions. So we have several examples of chemical reaction. Like right now we have the example of the rusting of the iron, or we can have some other examples. Can you guys think of some other examples of chemical reaction in daily life? Like digestion of the food in the stomach, that too is an example of a chemical reaction, where the acids, where the different kind of enzymes will be reacting with the food to break it into a simpler substances, right? Burning is a chemical reaction. Photosynthesis is a chemical reaction. Getting it, all of you?
Yeah.
Neutralization reaction, where an acid and a base reacts to give salt and water, that is also chemical reactions. So we have several examples of chemical reactions in our daily life. Some of them are like neutralization. The neutralization reaction takes place between two substances. Between which two substances, Vaika? Neutralization reaction, it takes place between which two substances?
Acid and base.
And what are the products that we get in this ream? What products do we get in neutralization reaction?
I don't know.
What about you? We get a salt and water.
Oh.
Got this one? Okay. Take for example corrosion of metals. Like we have the corrosion of iron, basically the rusting of iron. The process of digestion. In that, what happens? The food will be reacting with the acid plus different kind of enzymes that are secreted by the walls of the stomach. So there also a chemical reaction is taking place. Got this, no? Further, we have the process of respiration. We have the process of photosynthesis. Can you guys provide me the? Can you guys tell me what happens in respiration? The food will be reacting with which gas? Does it react with oxygen or carbon dioxide? Yes. A simple question is how respiration is a chemical reaction. Yes, Reem. How is respiration a chemical reaction?
Respiration.
Mm-hmm.
I don't really know. Actually, like first
So
we take in oxygen, then it's converted into carbon dioxide. Like we release carbon dioxide.
yeah,
Okay.
sir.
Okay, you have some idea.
And converting it into carbon dioxide and exhaling it.
Good. So basically what happens here, the air that we inhale, we mainly take oxygen from the air that we inhale. So the glucose is broken down with the help of oxygen to release carbon dioxide, that is CO2. I'm writing in short, hope you guys can understand this. That is carbon dioxide, that is CO2. And then water is also formed. Apart from this, the main thing is energy is also released, right now. So that too is a chemical reaction because two substances have undergone a reaction to give several products, to give carbon dioxide and water. So that is a chemical reaction. And the property of one of the basic property of the chemical reaction is that in this new substances are formed. Like melting of ice, it's not a chemical reaction, it's a physical change. Why? Because new substances are not formed, it is still water, only the state has changed. But this respiration, this is an example of a chemical reaction because here two substances have mixed with each other to give a new product. Photosynthesis, I suppose both of you can answer this one, huh? Tell me the products that will be reacting in this.
Photosynthesis.
Oxygen.
Oxygen, sunlight.
Oxygen is produced now. It will be the product, guys.
Oh yeah.
Yes, sir.
Carbon dioxide.
Carbon dioxide and
Fluoro. No, I don't think.
Vaika? Water, no?
Yes.
Carbon dioxide plus water
Okay, sunlight.
Oh, okay, sir.
in the presence of sunlight. Basically, it will be the chlorophyll will be using the energy from the sunlight to combine carbon dioxide and water and form glucose.
The chlorophyll acts as a catalyst.
We can say that sunlight will be acting as a catalyst.
Oh.
Okay, no? So here what happens, the using the energy from the sun's light, in the chlorophyll, basically chlorophyll, what does it do? It absorbs the sunlight, right? Now it needs to carry it needs some energy to carry out this reaction. Now for any kind of reaction to happen, energy is required. So chlorophyll be absorbing the sun's light, and thereby carbon dioxide and water will be reacting to form glucose, that is C6H12O6. Along with this, oxygen is formed. So all these are some of the common examples of chemical reaction. That is something which we have learned. Okay. Now, what all these things which we have written here, now, like these things that you see here, we have written CO2, we have written H2O for water, we have written C6H12O6 for glucose, and for oxygen we have written O2. So what we are using here, we are using the symbols for different substances that have undergone a reaction. So talking about the chemical equation, the next topic that we are understanding here is the chemical equation. So chemical equation is nothing but it's the symbolic representation of a chemical reaction in the form of symbols and in the form of their chemical formulas. You have used the arrow sign here. You have used the plus sign here. You have used the plus and the arrow symbols here. And you have written the symbols for the chemical, and you have written the chemical formula of different substances that are undergoing a reaction. So talking about a chemical reaction in this, what happens? We have any given substance, like we have oxygen. What is the chemical formula of oxygen? The chemical formula is O2. Then we have iron. The chemical formula of iron is
Fe.
Fe. Well done. And we have water, for example. So for water, the chemical formula is
H2O.
H2O. And notice how I am using the symbols also, the arrow sign, the plus sign. So I'm using the symbol also, and I'm using the chemical formula also. And as a result, I'll be getting rust. Chemical formula of rust is Fe2O3 dot H2O. Got this now? So that is the chemical equation. So this is called as the reaction arrow. What do we call this?
Reaction arrow.
Reaction arrow. Okay, no? Further, these substances are called as reactants.
I have a doubt.
Yes.
Actually, I had this doubt for a long time. Like when we do the equation, like it forms rust. We know that. But how do we write the equations? Like, do we understand it or do we just remember it, like memorize it, all the equations?
Okay. See, as of now, you'll be required to remember these things. Okay. Now, once you get to the class 9th standard, 10th standard, there you'll be learning about the symbol of different elements. Okay. Now, like for oxygen, we simply use the first letter. For iron, we are using Fe. Why? Because iron, like in the medieval times, now the language of science was Latin, basically. In the medieval times, most of the work in science was done in the Latin language. Getting it now? So in Latin, iron is called as ferrous. So thereby, we use the first two letters. In Latin, iron is called as ferrous. Getting what I'm trying to say?
Yeah.
Okay. Particularly, if I were to say the word, that is ferrum, actually. So we use the first two letter here of ferrum to name this. Okay, no? Further, by chemical reaction, by observation, we learned that when oxygen and iron and water, when we combine all these things, thereby rust is formed. So when we observed this, when studies were done on this, so we found out iron is present in it, oxygen is present in it, and water is also present in it. So iron must have undergone reaction with oxygen and water. That's how we came up with this formula. Getting what I'm trying to say? Okay, no? So it is studied in the laboratory. Then that's how we come to the conclusion that okay, these things are present in it. Okay.
So if I'm asked to like form a equation like this, like
Mm-hmm.
Fe2O3, so how am I supposed to remember these equations, like oxygen plus iron plus water forms rust, and the rust equation is this? Am I supposed to remember this, or like is it like there is a formula or something?
Okay. See, first of all, now, do tell me, have you learned about radicals in your school? Have you been taught about these things like radicals and all that? Positive
Yeah,
radicals, negative radicals. Have you learned about these things?
yeah.
You have? Okay.
Mhm.
So first of all,
I've kind of heard of the word radical.
okay, you have heard of it. In
Yeah.
your school, has it been taught or not? And that's what I need to know.
No.
Okay, okay. Let me give a let me give an introduction to that concept first of all. Okay, now. Also, you guys tell me you would have learned about the ions or not? Ions, positive ions, negative ions, all those things you have learned.
Yeah,
Like
sir.
in chemical effect of electric current, you would have learned about it,
Hmm.
right? When electrolysis is done, I think in that you
Yes, sir. Yes,
have
sir.
learned about it, Vaika, right? Okay.
Hmm.
Let me give a very fundamental concept to you guys. See, when we look at the structure of an atom, we know it's the smallest particle of any substance, right now. Further inside the atom, we see that atom is also having some subatomic particles like proton, neutron, and electron. When we look at the center of an atom, right now we are learning about an atom. Okay, now why we are learning about this atom? Because I need to make you understand the concept of ions, which are the charged particles, positive and negative. Once you'd be learning about that, then you'll be learning about how this compound is formed. Okay, that is one thing. So let me hear me out. What I'm trying to say. So inside, in the center of the atom, you have proton and you have neutron. These are found in the center of the atom, and the center of the atom we call this as nucleus. Okay, now here P is for proton. Getting a dream, and proton is positively charged. It has positive charge on it. N is for neutron, and neutron does not have any charge on it. Got this, both of you?
Yeah.
And
Yes, sir.
now this that you see, that is called as the orbit. This bigger circle, that is the orbit in which the negatively charged particle called as electron revolves. It will be revolving around the nucleus in this orbit. Getting it now? Like it is not actually present there, but for convenience we are drawing it. Okay, now? Just like when you look at the orbit of the earth, is there an actual orbit of the earth in which it is moving, or is it just an imaginary line?
Imaginary line.
In imaginary line.
Imaginary line, no? So this is also imaginary line, by the way. Okay, so that is the orbit, by the way. So it's the orbit in which the electron will be revolving around the nucleus, and electron is represented by a small e, and it has a negative charge on it. Okay, now
Hmm.
in fact in electricity you would have learned that electricity is basically the flow of electron. Electricity is generated due to the flow of electron. You would have learned about it. Okay, now what we see that in an atom, it's not like only one proton will be found, only one neutron, or only one electron will be found. Okay, now different atoms will have different number of neutrons, and different elements have different number of proton, neutron, and electron in it. So what, let us say there is an element, and the atom of an element, let's say it has 10 protons. Okay, and it has 10 electrons. So you guys tell me, if it has 10 proton, can I say that it has 10 positive charges? Yeah. By the way, see this word positive now. In short, many times you will see that it is written like this. You write the plus sign and you write the last two letter of this, VE. Okay, now. So that is having positive charge. So how many positive charges are there? One proton has one positive charge. So 10 proton will be having 10 positive charges, isn't it?
Mm.
So far it is clear now.
Mm.
One electron has one negative charge. So 10 electron will have
10 negative charge.
10 negative charge. So when you see that in an atom, the number of proton and number of electron are equal, then it is said to be a neutral atom. What do we say this?
Neutral.
Neutral atom. Getting it now?
Mm.
Okay. Vaiga, you understood this also? You also got this?
Yes, sir.
Huh. Now what happens that if, say for example, if you were to look at now, if you were to look at the formation of water, so in that case is what happens basically. Say for example, take oxygen atom that is represented by O, for example. I'm talking about an atom right now, not a molecule. So that is O. And then take, let me just switch the slide to this here. So say you have atom of oxygen. Okay, that is O. Getting it? And in the orbit of the outermost orbit of oxygen, there are 1, 2, 3, 4, 5, and 6 electrons. Try to understand this. And say that you have the hydrogen. What is this? This is the hydrogen atom. The previous one was the oxygen atom. Getting it, guys?
Yeah.
Now, in the outermost orbit of the oxygen, we have one electron. You have one electron. There is another hydrogen atom here. There is another hydrogen atom. And in this orbit of the hydrogen atom, there is one electron. Now, understand one fundamental thing here, that this oxygen atom has how many electrons here? 1, 2, 3, 4, 5, and 6 electrons. What happens here now? This hydrogen atom will come close to this, and this hydrogen atom will also come close to the oxygen atom. And then what happens? The sharing of the electron will take place here. So it results in this. There is this oxygen, and there is this hydrogen. And now this becomes H2O. Why it is called as H2O? Because there are two hydrogen atoms attached to the oxygen. Getting it, both of you?
Mm. But how will we know that it's like two hydrogen?
Okay, 1 minute. Let me just complete this drawing. Okay. How we're going to know that two hydrogen atoms are there? See, there is something called as stability of an atom. Reem, you there in the class? Yeah.
Yeah.
Actually, on the outermost orbit of the oxygen atom, it will be stable if it has 8 electrons. Earlier, it had how many electrons? 1, 2, 3, 4, and 5, 6 now?
Yeah.
Right? In order to become stable, it shared hydrogen shared an electron with this. This hydrogen also shared an electron with this. So now how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. So if it has 8 electron in its outermost orbit, now this oxygen is satisfied. Okay, now does it need any other hydrogen? No, it is already satisfied with this now. So that's why only there will be 2 hydrogen. Okay, now also like this is a concept which you'll be learning in detail in the high classes. Just to answer your question like how this is formed, I am explaining this. Okay, now I know some of the concepts might not be getting, you might not be getting, but are you able to understand, or are you getting confused in this? Please tell me honestly.
No, it's like I'm able to understand.
Getting it?
Yeah.
Very good. Something similar happens in the case of other substances also. Here also, similar criteria applies. Got this, no? So that is the case. So hope you have understood the concept of the chemical equation. It's the symbolic representation of a chemical reaction. So where I say that these are called as the reactants, and here that is called as the product. Okay. Now the thing is that the oxygen or the iron or the water, The atoms of these things will be reacting in a fixed amount. It's not like you have 10 oxygen, you have 20 atoms of oxygen, and then the reaction is going to take place in a in the in an organized manner, in the random manner. No, it takes place in a well organized manner. So let us learn about the balancing of the chemical reaction of the rusting here. So the concept of the balancing here basically says that the number of atoms on the left side and the number of atoms on the right side will be equal. Getting what I'm trying to say?
Yeah.
Okay. Right now we are seeing that how many iron atoms are here? 2. The letter at the word at the base of this letter Fe here, it shows the number. Like if I were to write O, so only there is one atom. If I were to write O2, how many atoms are there? 2 atoms are there. And if I were to write O3, O3, it's the formula of ozone, by the way. How many atoms are there?
3.
3 atoms are there. Getting it now?
Yeah.
Okay. Now let's say in front of O2, if the letter 2 is written, if 2 is written in front of O2, then what happens now? This 2 gets multiplied with this 2. This 2 will be multiplied with this 2. And then
Yeah.
it means that it is O4 actually, meaning that how many atoms are there?
4 atoms.
4 atoms of oxygen are there. Got this now? Or say if you have Fe2, how many atoms of iron are there?
2.
2 atoms of iron are there. Good. Now say if I were to write 2 in front of this, so this 2 is going to get multiplied with this. Now how many atoms are there?
4.
4 atoms. Understood this concept now?
Yeah.
So that is one important thing to be kept in mind. Okay. Okay, now. So let me just give you an important concept here. Let's take H2O for example. Okay. How many atoms of hydrogen are here?
2.
2. And for oxygen it is?
1.
1. Very good. Now if I were to write 4 in front of this, then how many atoms of oxygen and how many atoms of hydrogen are there?
Wait, but 4 into 2, 8 atoms.
8 atoms of hydrogen.
Hydrogen.
Good. And what about oxygen? Oxygen has nothing, like it means it has 1 here now.
Yeah.
So 4 multiplied with 1,
1. 4, 4, 4.
there are 4 atoms of oxygen here. Understood this thing now, Reem?
No.
Similarly, you can understand it here as well. Okay, now? So let us learn about the balancing here. So the purpose of the balancing here is that the number of atoms on the left side, basically in the reactant, should be equal to the number of atoms in the product side. Okay. So let me clean this
Can I
out.
just go and get my laptop charger quickly?
Okay, okay. Yes, Reem, you back in the class?
Hello?
Yes, Reem, you there in the class?
Yeah.
Okay. Now I have written the names of the different atoms here, atoms of oxygen, iron, and hydrogen, and I have written the same in the left and the right side both here. Okay.
Hmm.
Now look at the number of oxygen. How many oxygen is here right now?
1.
No, here on this side.
Oh, 2.
Okay, you have to look into this equation. Okay, so 2 here. So let me use a different color. That is 2. And what about here?
Where? 3.
Oh, that is 3. In order to make it equal, what should I do? Should I multiply this 2 with 3? And
No.
I will get 6. And how about I multiply this with 2 and I will get 6?
Oh, okay.
Yeah. Okay, but in order to like I will have to put the letter 3 here now.
Mm-hmm.
3 2s are 6. That's how it will become 6, isn't it?
Hmm.
Got this, Reem, or not?
Yeah.
And here, how this 3 will become 6 if I have, so I will have to put 2 here now.
Yeah.
Got this now actually? Good.
But how will we know if you are putting the 2 on the iron or the oxygen?
See here, when we have put 2 here now, it is
Mhm.
put for oxygen and it is put for iron also. Now, number of irons atom from here, from 2 now it has increased to 4.
Hmm.
Getting it now? So now you tell me the number of iron here will be 2 times 2. As we know, this gets multiplied with
Yeah.
this now. So
4.
that is 4. But here it is 1 now, only 1.
Yeah.
So what should I do?
1 into 4.
1 into 4. So I should put 4 here now.
Yeah.
So now we are done with iron also. Oxygen is balanced, iron is balanced, right?
Yeah.
Okay. Also see here, if you were to pay attention here, oxygen is here, this one also, no? 3 2s are 6. We forget about this oxygen atom actually. 6 plus 1 is 7. Understood this now? And here we forgot about this oxygen atom also. 6 plus 1, that is 7. Getting it?
Yeah.
So now we are left with 7 oxygen atoms. Okay. Oxygen